generation, transmission, and distribution infrastructure, which can automate and manage the increasing complexity and needs of electricity in 21st century. The grid is presently the grid is operating. The grid is operating, but the new technologies are going to pose a lot of challenges to the system. The new technologies are nowadays renewable generation. The second basic, the second and most importantly, another new paradigm shift is coming into our lives. Is the way the transportation is transformed. Now electrical vehicles are coming in a big way, and the cost of electrical vehicles also compared to the regular IC engine based vehicles. So electrical vehicles are going to come, and they are going to vary the grid conditions in a great manner. And battery storage technologies. So to some extent in our homes we use inverters to some extent, but as the technologies in the battery storage, they are coming, as the news is coming, as per the news, the battery storage technology is going to change the way the grid operates in the future. That is the one thing. And another thing is hydrogen cells is also fastly emerging. Renewable technology and large scale power control systems using power electronics and automatic generation control that is going to come. So all these technological innovations coupled with information technology and communication systems, they are more and more they are giving different avenues. They are opening up different avenues for continuous evolving of the sector. This always the entire all these things are to serve the consumers in a better manner. Serve the consumers in a better manner doesn't mean that only serving the consumers for only 24/7, but not that is not the case. We have to serve the consumer with a reliable power, secured power, and cost-effective manner. Because we have environmental concerns also, and with the increase in the thermal generation, that is also the environmental pollution, environmental climate change conditions and all is a different subject. But what I want to tell to the audience is with 1 unit of thermal generation what we are using, we are almost releasing 0.7 to 0.8 kgs of carbon dioxide into the atmosphere. So that is the impact of environmental pollution. So central government of India and the state governments have different targets for reducing the pollution, so reducing the thermal generation. That's why they are started encouraging the renewables. Yes, India is a renewable rich country. We have a very good geography which promotes wind generation, particularly South India. All the major states in South India are bestowed with very good wind potential, and some part of western part of India also they have very good wind potential. And we are a tropical country. We have almost 330 sunny days in a year, solar days in a year. So there is a lot of scope for solar energy generation. So keeping in all these in view, the government is also promoting renewable energy generation. So renewable energy generation is posing different challenges and different threats to the grid operation. So how the integration of these renewable energy generation is changing the way the grid operates, has to operate, and it is always demanding for more and more technologies, more and more technological solutions. Because This is like this. Wind energy generation is not at all available for all the days and months, day and night. The wind generation is only available for 3 to 4 months in a year. The remaining part, the wind flow is there, but the generation is not that much. So if you install a 1000 megawatts wind plant, during the season, the plant operates at 1000 megawatts, whereas during the off season, the plant may operate at 100 to 200 or 250 megawatts only. 250 is also higher side. And when it comes to solar, it operates during only daytime. Mostly operates about 6 to 7 hours, 7 hours during the day. No, it starts producing from 7:30, and the generation starts receding from 3:30 onwards afternoon. The maximum generation will be there for 6 to 7 hours in a day only. So if you completely depend on renewables, the reliability is a problem. Where to get the power for nighttime use? Where to get the power during non-wind seasons? That is the major threat. Whereas the thermal generating plants, they can be made operational throughout the day, throughout the night. They'll be operating at a constant load throughout the year. That's why basically they are called base load plants. They can take up the base load in the load duration curve of a power system. They are called base load plants, thermal, nuclear, gas, and all. It is convenient, but thermal generation results in a lot of pollution. So we have environmental concerns with thermal generation. We have intermittency based constraints because these wind and solar are non-reliable. They are intermittent. They are infirm in nature. The generation is not firm. And if you see, if there is a wind park, if there is a solar park consisting of 1000 megawatts area, 1000 megawatts means around spread across 5000 acres of land. The thing is that even during monsoon season, if a cloud passes through that area, you can imagine how much of generation gets reduced in a drastic manner. 1000 megawatts generation will come down to 200 megawatts within minutes. And once clouds passes by, again the generator starts accelerating. The generation is increasing. So these kind of intermittency issues are posed by the renewable energy sources. Somewhere we have to address. We have to address invariably, because unlike the thermal generation where there is a lot of inertia is available in the system, but in the solar generation that kind of an inertia is not available, and everything comes and goes in seconds and just in minutes. So same is also the case with wind power also during season period. The wind suddenly speeds up. When it operates at a constant speed, but there are also lot of variations. So these kind of variations has to be properly addressed in grid operations. Now the grid has to be properly planned. The grid has to be properly operated and maintained to take care of all these ramifications, or to take care of all these variations, to take care of all these infirm nature, unreliable and intermittent nature of the renewable energy sources. Renewable is great. Everybody likes renewable. Everybody wants to go green. It's fine. It's environmentally good. And nowadays, wind and solar power is also less costly when compared to thermal power. But its integration into the grid and its maintaining and its maintenance offers a lot of challenges. So that's why the smart grid technologies to make the grid more and more interactive, more and more intelligent. These smart grid technologies they are being developed day by day, day by day. And continuing our discussion about what is a smart grid. A smart grid is an electrical grid which includes a variety of operation and energy measures, including smart meters, smart appliances, electrical vehicles, and such kind of resources and energy efficient resources. Not only green energy promotion, there are another two issues. Energy efficient, they are demanding a lot of technological innovations and interventions in operation of the grids. And next is the electronic power conditioning and control of the production and distribution of electricity are important aspects of the smart grid. Yeah, this is also new. With the advent of advanced power technologies, the control systems have increased, and here also in our end use equipment. If you see a lot of we see a lot of end use equipment with DC drives, inverter drives. So all these things are, and smart inverters. If you see end use equipment like refrigerators or air conditioning equipment, everything we use, every electric gadgets we use, washing machines. There are a lot of intelligence involved in it, intelligence inbuilt in it. Apart from this, nowadays in technological side, Internet of Things is also coming in a big way. So networking all these electrical gadgets and operating to remotely. So all these interventions, they are causing the grid to develop itself towards technological side, continuous development. So rollout of smart grid technology also implies a fundamental re-engineering of the electrical service industry focused on the technological infrastructure. So earlier, 30 years back or 40 years back, the grid, the first objective of the grid is to supply power to the consumers without any interruption. So at that point of time, there were no good technological tools are there. They depend on only telephone technology. Only telephone is there. There was no internet, and electromechanical frequency meters they used. It is difficult to visualize difficult to see the bus voltages in a spatial map. If any bus voltage problem is there, they have to call up the local that concerned substation and record the bus voltage manually only. So from that stage, now we have reached, thanks to the technology, we have reached some stage. Now from this stage, we have to again go forward. And now the steps now, what we take from now onwards, they are very bigger because of the advent of renewable technologies, storage systems. There is a lot of, that's why if you see the Indian government has also taken a lot of initiatives. They have formed an Indian Smart Grid Forum, ISGF. You can browse the web. They are taking a lot of initiatives. They are creating a lot of outreach. They are creating a lot of awareness on smart grid technologies. What are the different technologies that are coming up? What is there? Some countries are doing, and like that. Yeah. Last, this is my statement. Smart grid is not static. Smart grid is not a static, like it's an equipment. This equipment is smart grid. Like that, we cannot tell. It is continuously evolving. Now we have reached some stage, and from this stage, we have long way to go again, because of the different challenges day by day that are coming up. If you see, even 25% of vehicles that are being used now, if we convert into electric vehicles, so you see what happens, how much power you require, how to build the charging stations. So this lot of smartness or intelligence is to be built into the grid in the coming years. So that's why we can say the smart grid is a continuously evolving process, and we have to catch up with the pace in the technology. Yeah, these are the main comparisons between existing grid and smart grid. We will also see what are the interventions, because our focus point of the topic is renewable energy sources and how to integrate. What are the challenges that renewable energy sources are posing to the grid? In the renewable energy front, nowadays we have rooftop solar technology. Most of the people can install a solar power plant on their roof, on their rooftop at home or institutions. People must be seeing, if they visit any local rural areas, there are a lot of agricultural pump sets are also there. Solar agriculture pump sets are also there. Not only a consumer not only consumes, he also generates, produces. That's why the central government is also giving a new definition called prosumer, consumer plus producer. So the production at the receiving end, production at the usage end is to be promoted, because there will be there will not be any losses, and the generation happens at a local at the consumption area is good. There is no locus, there are no losses, and the generation can be used directly. There are a lot of advantage to it. So that's why particularly this is enabled. Particularly this is made possible because of solar photovoltaic technology. Now the consumers can not only generate and consume by themselves, they can inject the power into the grid as well, back to the system. So that's why is a two-way power flow is there. The power flow is bidirectional, as shown in the 11th point of the slide. In the earlier grid, the existing grid is only a conventional single directional flow from generator to the consumer. Whereas in the smart grid technologies, they enable power flow. They have to enable power flow from consumer end to the generator end. Not the generator, network. They have to enable injection of the power by the consumer into the network. This is necessitated because the consumer renewable energy technologies, solar panels are coming at a cheap cost. Consumer are able to install the solar power plants at their rooftops. This one is one aspect. And with the nowadays, the metering technology is also, all meters are smart meters, or IRDA port meters and infrared devices. Meter reading can be taken without looking at the dial and noting down. A metering instrument, if you place that metering instruments near the dial, you can read the meter. Nowadays, the spot billing is exactly happening with that kind of a technology, infrared technology. You don't need to read the meter and note down the readings or punch the readings in a machine. Am I audible?
Yes, sir.
Hello? Any issue? No issues, na?
No issues.
Okay. These smart meters are also part and parcel of smart grid technologies. Earlier, there are other issues called measures called demand side management measures. That means if there is any demand because of supply constraints, and we can manage the demand, or we can ask the consumers to participate in certain kind of a demand control measures or demand side management efforts.
Sir?
Hello, sir.
Hello, sir.
Yeah. Some network problem here in my side. So sorry.
Okay, sir.
Sorry for the inconvenience. Yeah. I'm continuing.
Okay, sir.
Yeah. These are the comparisons between the existing grid and smart grid. As of now, the comparison is existing grid operates are mostly electromechanical with limited digital instruments as presently. So smart grid is a completely digital one and one-way communication. It facilitates only one-way communication, whereas in the smart grid, the two-way communication is possible. Both not only the communication from generator side to consumer side to generator side, power flow is also possible. And this existing grids, there's a lot of centralized generation, and smart grids, they provide a lot of facilities, scope for decentralized distributed generation. This decentralized generation based on the local resources, like any vacant lands are there, they can we can install local generation. A mandal which consumes around 5 to 6 megawatts. If there is any if there is any vacant land is there, we can install solar generating plant, so that the entire mandal can be fed from that solar plants. And it consists of a few sensors. As you know, it's a sensitive electronic equipment for transducer equipments for reporting different parameters, and manual restoration. And a smart grid gives a self-healing. Any outage is there, it automatically restores it back to the normal position. And failures and blackouts. If there is in the present system, if there is a grid failure, we have to go to that location, we have to rectify the system, and we have to switch on the system back. Whereas in the completely smart grid technologies, there are adaptive and islanding mechanism all there. Even now also some kind of an islanding mechanism are there in the grid operation, particularly for cities, major cities. But for the entire grid, this islanding mechanism can be operated, adaptive controls and self-healing techniques. That means any outage is there, automatically the power will be routed to the isolated section from another alternate lines, like that. And in the present system, the consumer choices are very less, very few customer choices. In the smart grid technologies, there are a lot of customer choices are there. In terms of time of the day tariffs, and we can stagger, we can shift our consumption from one time to the other time, because nowadays our end use electronic equipment are also getting programmable. We can place our clothes in the washing machine and set a program that to run the machine at a particular time. It's like this. If afternoon tariffs are lesser in an area, now when we go to the office, we can place the clothes in the washing machine, and we program it to operate during the afternoon time automatically when the tariff is less. Then it could happen that the machine starts operating during the night, during the intended time, and you can save the money, because maybe nowadays in the domestic sector these kind of rates are not there, time of the day tariffs are not there, but whatever energy you are using, you are paying at the single tariff throughout the day. But whereas in certain particularly industrial sector has time of the day tariff as well in the present system. In AP, Telangana also has time of the day tariff system. So all these kinds of automations happening not only in the industrial sector, in the domestic sector also, as I am telling you, there are a lot of automations are there. You can program your air conditioning machine also to operate, or you can program your washing machine, whatever like that. And you can program your lighting. You can change the light intensity as well as number of lights glowing at a time in a home. All these kinds of all are the interventions. They create smart grid. They give more and more consumer choices. And what are the we just quickly go through the as part of this lecture, we quickly go through what is happening in the renewable energy sector across the country. Just in quick slides. Honorable Prime Minister has set up a national solar mission in the year 2008. And as you are all aware, National Action Plan for Climate Change, we have committed as part of National Action Plan for Climate Change in the COP22 summit. And as part of that, we have 8 core initiatives. And NAPCC identifies measures that promote India development objectives and also yielding core benefits for addressing climate change of electricity, climate change effectively. So in the Paris Agreement signed in 2016, India has committed to an integrated, intended, nationally determined contributions target of achieving 40% of its total electricity generation from non-fossil fuel sources by 2030. That means we committed to generate 40% of our total electricity generation from non-fossil fuel renewable energy sources like solar, wind, biomass, bagasse, and all these things by 2030. So in the coming 10 years, we wanted to shift to 40% of renewable energy penetration. Only certain states presently, they have crossed 15%. Only certain states. Across India, it is only 10%. So AP is also one of the state. We have almost touched 21-22% of renewable energy generation in the country, in the state. If you take the state's consumption, out of the 100 units, almost 22 units are being generated from renewable energy sources. So we are one of the AP and Telangana also, because Telangana, they have a lot of solar plants they have set up. So in the entire country, the intention is to go to renewable energy generation by 40% in the year 2030. So this national solar mission contemplates increased share of solar energy in energy mix, decentralized generation and distribution of solar energy, creation of more affordable, convenient solar power systems and storage, promotion of clean technologies involving solar PV and solar thermal generations. These are the solar mission objectives and targets fixed by Government of India. 175 gigawatts. Gigawatt means 1000 megawatts. 1,75,000 megawatts of renewable capacity by 2020. And out of 175 gigawatts, 100 gigawatts is to be achieved from solar. And please see the last two bullets, last 2 points. India has a huge potential for wind and solar. We have almost 300 gigawatts of wind potential and 800 gigawatts of solar potential. If we could harness this potential even to 50%, the entire energy needs of India and the entire energy needs of the country can be met for the coming 50 years. That is the potential we are having in terms of renewable. That's why the government, state government and central governments are concentrating more on promoting renewable energy. That is the reason why the more and more penetration of renewable energy into the grid, the more and more technologies we require to meet the challenges that are posed by the wind generation and solar generation. What are the challenges again? The generation is very intermittent. The DF by DT, what it called, the DF by DT is very high. The rate of change of frequency with respect to rate of change of time with the renewable sources. Like the solar, as I told you, if a cloud cover comes, the entire generation drastically drops to 20% or 10% within no time. So these are the challenges they impose on the grid, and we have to be ready to counter that challenges. So that's why we have to adopt more and more technological solutions, more and more sophisticated equipment, more and more innovations. So most of the innovations that are being coming today, they are already being adopted into the grid management. So like smart meters, we have adopted smart meters, and SCADA systems. We have adopted SCADA. Almost every state is having its own SCADA system for system operation control, power system operation, and power system monitoring. So these are the composition of installed capacity in India. The solar and wind generate only 80% of total electricity shared of total in 2018-19. These figures are given for the 2018-19. Now the generation mix has also increased. Renewable energy generation across the country has touched almost 15%. Even now, 15% generation is not sufficient. We want to reach to 40% in the coming 10 years. So just imagine how much of effort we have to put, or how much of interventions we have to make, how much of investment potential is there in this sector. Because each and every 1 megawatt of solar or wind plant will cost you around 3 crores to 4 crores. So a lot of investment is required to achieve this. Solar plants, even though the technology is coming down, in the coming 10 years, there is a lot of improvements. I have seen solar plants rates each and every unit now the rates have come down to 2 rupees 50 paisa. in the coming 10, 12 years. You can change how much rapidly the rates have come down. That is the reason why the people are ready to adopt. That is the reason why the solar plants are also coming in a big way on a parks basis. Mega each and every park. Well, is it okay, sir? Hello, am I audible?
Yes, sir. Audible.
Okay. Yeah, I was saying about solar plants, the cost of the solar plants, and cost of the thermal plants. So that is the future lies in solar and wind generators because of the cost constraints. We know the renewables cause a lot of problems in the grid operation, but they are very cheap. We cannot afford to lose the cheap generation. So that is the reason why we have to continuously search for new technologies that are adaptable, that can be adopted for integrating more and more into the grid. The renewable energy promotion is also from different sides. The renewable energy is being promoted, particularly the solar. One side, large-scale solar plants are promoted in the parks, and another side, in the lower end, rooftop solars are also widely promoted. A lot of institutions, a lot of engineering colleges, universities, and industries, they are going for rooftop or ground-mounted solar plants. So the ground-mounted solar plants and rooftop plants, they generate during only, if it is a solar plant, they generate during only daytime. And nighttime, again, the consumer, the utility, the unit has to depend on grid power. And when it comes to the wind is available only during the season. So all these things we have to address for evolving towards a more and more integration of solar and wind energy as contemplated by the central government in their targets. So this is the growth of renewable energy capacity in the country for the past 10 years. In the year 2010, there is only 14,000 megawatts available. Out of that, is only 1 megawatt or 10 megawatts is available in solar, wind around 13 megawatts. Now you see, by March 2020, we have almost reached 87 gigawatts. That means 87,000 megawatts. And the target for 2022, in the coming 2 years, 175 gigawatts. And by 2030, the target is to reach 450 gigawatts, 450,000 gigawatts. The total presently, all these numbers you can glance in the net. Presently, the total installed capacity of the country is around 360,000 megawatts and so. After that, 360,000 megawatts or 340,000 megawatts, 87,000, 90 gigawatts is from renewable energy sources presently. So, because there is a comparison. 1 megawatt of thermal power is not equivalent to 1 megawatt of renewable power, because the renewable power operates only for only 25% of the time. Because only solar is operative only for during 6 to 7 hours in a day, and wind is only operated for 3 to 4 months in a year. So, if you want to meet an equivalent energy, if you have 1 megawatt of thermal generation, you need to have 3 to 4 megawatt of renewable energy capacity to meet the requirement of energy, to meet the requirement of same quantum of energy. That is the reason why if my thermal generation is around 2 lakh megawatts presently, 2.2 lakh megawatts presently, in order to meet my energy needs, if I want to meet 40% of energy from the renewable energy sector only in the coming 10 years, so you just imagine how much additional capacity I have to make. So this additional capacity causes a lot of problems. basically this is like this. Right from connecting to the grid, it creates problems. Ideally, in a power system planning, the generators have to be planned at the load centers. When it comes to renewable, we cannot plan it at the load center, because at the load centers, the land cost of the land is high, and the renewable energy projects require a lot of land, particularly solar. When it comes to the wind is geographically dependent. You cannot have a wind generation at Vijayawada, just like we are having a thermal generation at Vijayawada. The wind profiles are the geographical area profile is not encouraging to have a wind generation here. So the wind generation has to happen in wind dependent zones, wind zones only. And fortunately, AP is having two major districts, Anantapur and Kadapa, and Kurnool also to some extent. Major wind zones are there, so a lot of wind generation is happening there. The problem with the renewable energy is we cannot decide the location of the power plant. So once we cannot decide the location of the plant, then we have to lay long transmission lines to bring the power to the main grid and main usage point. That is the first threat the renewable energy sector is posing to the planners. When once you draw a long distance lines, the long distance lines cause voltage problems during light load conditions due to parent effect. Then because of this long lines, again we have issues with regard to, just a minute. These long lines, we have issues with regard to voltage problems. And the second point is during scheduling and dispatch. The grid operates on a scheduling and dispatch principles. On a day-ahead basis, unit commitment we have to drop, and whatever is the generation commitment, that has to be stick. Whereas with the renewable generators, we cannot have a unit commitment matrix. We cannot have a unit commitment problem, because it depends on the nature, vagaries of nature. We expect wind will be in a particular pattern during day ahead, but during the day the wind may not be in that pattern. Solar is not in our hands. Is subjected to a lot of vagaries of nature. So that is the problem. So during the scheduling and dispatch also there are a lot of problems. That's why state and central government agencies like regulatory commissions, they are continuously giving spree of regulations, various regulations that are required for better operation and control of the grid, with kind of inadvertent or intermittent power of wind and solar generation. This is the second point. The third one is we have to promote, we are giving options to the consumers also to go for wind and solar generations at their rooftop, at their vacant lands. So commercially, we are giving options to pump the power, surplus power if they have, after completing their usage into the back to the grid through a net metering process, and we can pay back to the consumers. So a lot of consumers they are coming forward to install the power plant, install the local generation, rooftop solar. And this is going to give another thing, because our distribution networks, they are meant for one-way flow, unidirectional flow of power from generator to the local consumer. Now the power is going in a reverse direction. If the power is going in a reverse direction, there are a lot of issues are also there in terms of security, manual security, man security, and commercial issues. Now that we thought there will be 100 megawatt load, but during the daytime, it is only 10 megawatt generation instead of 100 megawatt load. We have to plan in a different manner. That means if most of the consumers take up local solar generation, then where to dispose the surplus power? It is an issue. And some consumers, there is another facility also in the system. It's called open access. That means bulk consumers, bigger industrial consumers, they can have their own generation plant and can use the power at a different location of their use by making use of the system by paying some charges. And these open access transactions, they also cause a lot of, particularly if they are from renewable energy sources, they cause a lot of intermittency issues. Because I cannot, if my consumption is 200 megawatts, I cannot ensure on a real-time basis my generation is also 200 megawatts at my generator end. Because if I am an industry, I have set up an industry in Hyderabad and my wind generation is in Anantapur. So I cannot minute to minute match my wind generation here to the to my consumption at the location, load location. So wind generation, sometimes wind generation surpasses the consumption. And during that time, we cannot back down our thermal generator system operator. So we have to absorb the entire wind generation. And during the night time when the wind generation or solar generation was not there, I was forced to give to the supply to the consumer from our generators. So this is called balancing issue, balancing of power. There are a lot of balancing requirements are there. There are a lot of transmission issues are there, as I said, because we have to lay far-flung transmission lines to evacuate the power from renewable energy sources. And these far-flung lines, in the light-loaded conditions, they generate a lot of reactive power. That is also an issue. And all these inverters used in solar power plants, like solar panel after all generates only AC power. It will not generate DC. Whereas the DC is to be converted to AC again before getting synchronized to the grid. So all these inverters consume a lot of reactive power and harmonics also, because all are the electronic equipments. So there are a lot of ill effects of harmonics in the system. We have to do harmonic filters, we have to do smoothing, harmonics, everything we have to do. And reactive power problem, as I said, voltage is also one of the criteria for grid management, and reactive power flow causes havoc to the voltages. And nowadays, even the wind generators are also the doubly fed induction generators particularly, and variable speed wind generators. They are all are having again conversion inverters. The variable wind speed generators generate power, and that power gets converted to DC first and again converted back to the AC at a constant frequency, because if the variable speed wind generator has to be synchronized to the grid, it needs to generate at a constant frequency. So frequency is very important, grid frequency. So again, converter inverter sets are there. Because of the conversion inversion, there is a lot of reactive power and harmonics. And these harmonics, they have a lot of, they create a lot of problems in the grid. They can cause mal tripping also. So these are the constraints with regard to integration of more and more renewable energy into the system. we have to plan accordingly based on the latest technologies available, based on the innovations that are coming up. Nowadays, for all these renewable energy parks, renewable energy management centers are set up locally. So they do some kind of a forecasting, how much about the wind forecasting and solar energy forecasting for the day-ahead scheduling of the system. So this is also one of the research area where in the wind forecasting, renewable energy generation forecasting is also major research area. Lot of research is also happening there based on weather conditions, based on geographical conditions, based on temperature, based on moisture, the atmosphere. All these things are affect the generation pattern and wind flow pattern and solar generation. Solar generation, the major problem is if there is any, because it doesn't have any inertia, whatever the change happens at a very rapid pace. You know, wind generation, the retardation, the deceleration is lesser when compared to the solar. Solar almost trips at an instantly. The solar generation, if a cloud comes, the entire power gets reduced to almost 20% or 10% of the capacity within no time. That is the problem. So if just assume in a situation where the grid is operating at a 10,000 megawatts capacity and suddenly 1,000 megawatts of solar capacity has gone. Now, either immediately I have to shut down 1,000 megawatts of load, or I have to jack up my generation from the existing plants to the extent of 10,000 megawatts. If my generators are all operating at full, I don't have that option. Then I have to search for whether I can overdraw from the other grid to get the power, or else I will have to shed the load. I cannot shed the load in the same pace as that of my generation has gone down. That is the problem. Load shedding is a different problem. So load controlling is also one of the factor. Load controlling is also one of the factor in smart grid technologies. We have to segregate the loads into interruptible quantities and interruptible feeders. And we should be able to control the loads automatically from the control room. The existing SCADA systems and the distribution automation system or distribution management system that are being implemented, substation automation system, these are all these kinds of automation systems that are being implemented can facilitate in future for automatic load control as well. Otherwise, what to do? From the control room, we have to call up the different substations and ask them to act immediately to curtail the load. They switch off the feeders manually. But in the coming years, with smart grid technologies, you can do that also. Automatic load shedding can be done, has to be done because of the inadvertent nature of the generation, wind and solar generation at the other end. If we don't do the automatic load control, then this will be a very this will certainly pose a great risk. Yeah, this is the this graph I wanted to show. This is a typical AP Transco grid demand during a day. The grid demand is during the October. This is during the month of October, the first day of October, I think. This one. The grid demand is hovering from 6,300 megawatts to, and it has reached to peak during evening at 8 o'clock to about 7,500 megawatts. And this is the bottom one is the thermal power, the black one. You see the below the red is the others market purchase and all. Below the red, there are two strips are there. One is wind and another is solar. The upper one is solar. That's why that's shown during morning say 6 to evening 5, like that. And the lower one is below that is the wind generation. You see the wind generation pattern. It is not constant and uniform. It varies in accordance with the flow of wind. That is again geographically dependent and this thing. And the wind, as I said, the wind, there's a lot of wind generation, and solar is only available during daytime. But even if it is available, it always comes as a bell curve on a day-to-day basis. So these two are the intermittencies that cause the grid operator for adapting to more and more sophisticated technologies. In the next slide, we can see this gives you the numbers. This is the solar power and wind power, and what I mean to say is that the solar generation, wind generation, will not follow through the load, because load has to be followed through by generation. Otherwise, load generation balancing on a real-time basis is not possible. Load generation balancing is real-time operation is not possible. That means the frequency of grid frequency varies widely. That is not allowed by the regulators. The system operator has to make sure that the grid frequency falls within the band, always. So if he has to see that the grid frequency is only below, be within a band, that also is a narrow band of only 0.2 to 0.3 hertz. Then you see how he has to manage the load and generation. That is very important. The renewable generation is very intermittent, unrealistic, unexpected. Whereas the load we can expect to the reasonable extent on an aggregate basis overall. Because okay, even though load varies from time to time, but the variation in the load, okay, certainly if you see the load pattern in the upper in the graph, if you see the upper line, the load pattern, it is almost constant throughout the daytime, night 1 o'clock to evening 5 o'clock, then gets peaks up because of the evening lighting load. Then again, when once during the night, it again falls down to the base load level. So there is not much variation, we can say, in the load demand pattern. But whereas in the generation pattern, if you increase the penetration of wind and solar, there is a lot of variation in the generation pattern, and this cannot match into the load pattern of the system. So the remaining gaps are to be filled by thermal generators and other generators. And in the early parts of our presentation, we have said that there's going to be a storage systems are also coming up. If the storage systems, grid connected battery storage system comes in a big way, is helpful, so that the surplus solar power and surplus wind power that is available during certain seasons, or surplus solar power available during daytime, can be stored into the grid. Now this is similar. This is similar to what we are storing in an inverter in our home. Whatever power is available during daytime, we store it in the inverter, and then, but inverter we use it for as a standby purpose. When grid power is not there, we use it as standby purpose. But the grid parity, grid storage battery systems, they are not as a standby purpose. They are for absorbing the surplus solar capacity available during daytime and giving the electricity back to the grid during night time when the solar is not available, so that we need not plan again the thermal power generation to supply during the night time. So whatever energy stored during the daytime with surplus electricity can be used. So this kind of the new grid mounted grid parity and grid connected battery generation systems are also coming up, and certain countries have also done that, and we are also in the process of adopting the same. They are also very much necessary. There is another thing is also called pumped storage hydro plants. They are also very much coming up nowadays. So whenever there is a surplus power, the water in the reservoir gets pumped back into the reservoir, and during the peak load hours or during the needy hours, the water can be brought down from the reservoir to the downstreams to generate the power. So these are all required because invariably the base load has to be met by thermal plant. And we want to increase the penetration of wind and solar into the system. So thermal plant we cannot operate on an intermittent basis because it is a base load station basically. So thermal plants, it takes a lot of time to start the generation and reach to a level, and even to accelerate or decelerate the thermal generation, it's a lot of time is taken, and cost also nowadays. Cost of the thermal generation is also higher. So all these things, it is difficult to operate thermal generating plants at an intermittent operator, intermittent station. So we need to have a grid storage, or we need to curtail the renewable generation. Curtailment of renewable generation again is a problem because it's coming at free of cost. Why should we waste the natural energy coming from nature at free of cost? Those kind of issues will come. So these two are just I wanted to show you how the load and the generation pattern behaves, and how all these I'm just classifying and segregating different threats involved and technologies available. Threats imposed by the renewable energy generation, and what are the different kind of technologies nowadays available. And there is another thing is also called, if the peak in the demand side management efforts, there is called peak clipping and filling of valley in the load curve. That means if my base generation is 7,000 megawatts flat throughout the day, and just during the evening for some 3 to 4 hours my generation is increased, my load requirement is increasing to 10,000. That means 3,000 megawatts of power you are requiring only for 3 to 4 hours of a time. Just for that 3 to 4 hours in a day, you cannot install a big generating plant for 1,000 megawatts. Then we can do some kind of a load management or demand side management, by which you can facilitate that, you can ensure that your consumers will not switch on the load during that time of 3 hours to be able to cause a load, on that basis. Just a minute, I am just attending one call. Kindly hold, be patient. Hello, am I audible, sir? Hello?
Yes, sir. Audible, sir.
Okay. Thank you very much, sir. Okay. So these kind of demand side management efforts that are required for clipping the peak demand, so that it is not required to generate 3,000 megawatts or 4,000 megawatts, whatever it may be, for the shorter periods. In the present grid conditions, this could happen only through load shedding. During the evening time, we will shed the load on a roster basis and ensure that we stick to our the generation. But in the smart grid era, what we can do is we can set up we can communicate with the consumers directly, and we can ask them to reduce the generation or program their loads. Like like I told you about washing machines. Now we ensure that washing machines does not come onto the system during evening peak hours. We ask them to program that washing machine load to the afternoon hours or evening hours or night hours. These kind of interventions can be made through a smart grid. And load curtailment also. Now, if you do load curtailment manually, it is always subjected to the discretion and favorism. If I allow it to my ground engineer, my field level engineers, they may not act in strict protocol. Like if I say, okay, for half an hour you cut to this area, and another half an hour you cut to this area, you rotate this so that everybody will be covered and nobody will be annoyed. So ensuring such kind of protocol with manual interventions is difficult. But in a smart grid system, where you have load control, automatic load control systems, based on a preset program, the load is cut automatically for that kind of a time period as is programmed, and the load is restored back onto the grid immediately after favorable grid conditions are achieved. So these things are required with the increased penetration of wind and solar systems. Yeah, these are the next one is the smart grid. What are the various technologies that are being adopted for better management of the smart grids nowadays? Nowadays, as I said, there are SCADA systems, supervisory control and data acquisition. This SCADA system collects data from all the feeders in the substation, major substation, and stores on a 20-second or 25-second polling basis. And again, the data is analyzed, and the data is shown in the control room to the system operators. And phasor measurements units are also there. Phasor load angle measurement. There's load angle measurements units are installed at different places, geographical locations, so that because the swing curve constraints and load angle constraints, if that load angle increases to more than the threshold level, automatically the generator gets tripped off. So,
Sir, sorry for the interruption. Slide which is there on screen, growth of renewable energy capacity in the country.
hello, yeah.
Slide is not increasing.
Slide has not changed, madam.
Yes, sir.
Now?
Still, it's growth of renewable energy capacity in the country. Slide number.
Okay. Then I will again reshare. Just a minute, we'll hold on.
Okay, sir.
Yeah, now change it.
Yes,
Hello?
sir. Please change it.
Okay, now you are able to see the graph?
Yes, sir.
Okay.
Typical grid
And-
demand during it.
Yeah, this one, this one was not visible last time.
Yes.
Few minutes back as well. Okay. Yeah, this is the AP Transport typical grid demand curve. And I have shown, this is the load, total load that is being met from different resources. These two are the basically second one and third one from the top are that green power is the basically renewable energy. One is solar and another is wind. The wind is there throughout the day at different levels, whereas the solar is only available during the daytime. That was I was showing. So this is the load pattern, and as I said, the load, the wind and solar generation cannot follow through the load in an exact manner because of the wild variations in generation of wind and solar. So now we are features of smart grid and equipment we are discussing. I was saying about the phasor measurement units and the automatic generation control also. If at any point of time, if our load is more than the generation, if the generation is more than the load, then you will be able to control the load, control the generation automatically from the control station. And now flexible AC transmission systems are also available, PACS devices and static compensators. These two are for addressing the voltage problems and higher transmission capacity issues and all. I was discussing about that peak curtailment and leveling and time of use of pricing. As I said, if the peak demand in the system happens to be only for a couple of hours or 2-3 hours in a day, then you may require to clip the load, clip the peak demand, or level the load by using a time of day metering, because you require smart meter plays a vital role in creating smart grid. Smart meter by mean it records your consumption on a time block basis. Every 15 minutes, how much you are consuming, it will records and it stores the data. Nowadays, in ordinary metering, what happens? You see if I come for a reading, if our linesman come for a reading, it takes what are the previous reading and what is the present reading. The difference will be taken as the consumption. But in the smart meter, the consumption will be time stamped, and in which time block or which part of the day you have consumed how much is recorded and stored in your in the meter. So this time stamped data is required if I want to give you a time of use pricing. If I say if you use the power during daytime, if you use the power during peak hours, I will make a penalty of 1 rupee extra. Then how you can segregate the consumption? In the ordinary meters, that cannot be done, because the ordinary meter reading gives integrated value from the starting of the month to the ending of the month. Whereas in the smart meter, it gives a time stamped value. The meter data, once I reconvert back, we can convert it back into a database. Then we can fetch how much is the consumption for during every day during peak hours. What is the cumulative consumption, and I can make the penalty for 1 rupee or 1.5 rupee, whatever it may be, we can levy on the consumers. So presently, this time of the day metering are implemented for industrial consumers and big commercial consumers also. In the coming days, the time of the use meters also come for domestic, because domestic consumption, domestic area is a lot of with the advent of this Internet of Things, and with the advent of this automatic appliances, there is a lot of potential to do that. Particularly in the household sector, we can control the lighting, we can control the air conditions. You can say don't put on your air conditioners during the peak load hours of evening 6 to 10, and don't do the like washing machine, using of washing machine or whatever. All these kinds of things can be done. This is also a part of demand side management or load control measures. All these can be done by means of smart meter installed at the home. So that's the reason why smart meters also form part of the upcoming smart grid technology, smart grids. As I said, the smart grid is not a final, it's a continuously evolving one. If we see, now the distributed generation is coming in a big way. Distributed generation, I mean the solar and solar rooftop technologies. Now battery storage technology will come in future. And there is a ring main units. There is a distribution to give alternate supply immediately. There is an equipment called a ring main unit. That means with multiple incomings and multiple outgoings. This ring main unit ultimately can automatically switch on to an alternate source if there is an interruption. There are continuous process loads in certain industries, critical process loads. They cannot afford to lose the supply even for a minute. So for those kind of systems, once if there is an outage on the one feeder, the power gets automatically shifted to the another feeder. These kind of ring main users, the reclosers are there, sectionalizers are also there. These are the different kind of equipment in the network. The ring main units, reclosers, sectionalizers. Sectionalizers, what does it do? In the faulty conditions, it automatically sectionalizes the fault section and restores the supply back to the healthy section. But nowadays it has to be done on a manual basis. But with the advent of the new technologies, auto reclosers are there, auto sectionalizers and substation automation systems. All these things are as a step-by-step process leading towards the smart grids. These are increasing reliability and economic operation, and energy efficiency equipment is there nowadays. Load balancing, DSM for smart meters I have told, energy storage systems, substation automation, and distribution management system and distribution automation system. And electric vehicles are also we have discussed. Electric vehicles are also going to be the form part of smart grid. In the night time or in the peak load time, they can discharge back their battery into the grid and pump into the grid when the grid needs really. Because each and every battery stores around 20 units, 20 kilowatt hour. So the energy can be pumped back into the grid if the grid is in need during evening peak hours. At that point of time, when the power cost is higher than the 10 rupees, then the electric vehicles also form part of smart grid technology, smart grid interventions. Or whenever there is surplus solar power is there, the electrical vehicles will be promoted, will be allowed to get them charged during the daytime only. I don't allow them to charge during the night time when the power is costly and the peak demand conditions. And nowadays in metro trains and ordinary railways also, all the locomotives are fitted with regenerative braking. So nowadays all the cities are going to have metro trains run on electric traction. So all those kind of locos or metro trains and ordinary regular trains for goods transport, they are going to be fitted with regenerative braking thing. So that the braking is so that during the braking time the motor acts as a generator and pumps back the energy to the grid. So this is also one of the coming years. This is also the smart grid intervention. And as I said, the smart grid requires the bidirectional flow, not only the bidirectional flow of communication, it's also bidirectional flow of electricity from generator to that's why, as I said, the Ministry of Power is also terming the consumer as prosumer. It can be a producer sometimes, or it can be a consumer. So all these latest equipment, they are helping in evolving of slowly and steadily evolving of smart grid technologies. But because whenever we are prone to a challenge, then we innovate certain things. So that's why it is a day-to-day happening. It is a continuous process. The large-scale wind turbines nowadays are coming up with 6 megawatts or even 8 megawatts of single machine turbines are coming up. Earlier, it was only 0.25 megawatt turbines were there 10 years, 15 years back. And solar panels are also, because of the advent of the technology, solar panels are also not only the cost, but also the conversion efficiency is also higher in solar plants. So slowly and steadily, the world, in particular this energy sector, is going towards efficiency, because nowadays the cost of wind and solar, they are very much lesser, up to only 3 rupees or 3.50 paisa, whereas thermal power is very much costlier. And now the major change is going to happen in the transportation sector. the major change is coming. Now you can see at least one in every 10 vehicles, one electrical vehicle in every 10 ordinary vehicles in the coming 2-3 years. And as you observe, there are a lot of models are coming up nowadays into the electrical vehicle market, and each and every major manufacturer is having a model. And the government is also very much promoting the EV technology and EV charging stations for slowly avoid the oil imports, basically. So these EVs, the upcoming EVs, the charging stations, the battery storage technologies, and higher capacity wind and solar power plants, because the government intention is to, in the coming 10 years, almost to go to another 3 lakh megawatts of solar and wind power. And as I said, the length of the transmission lines is going to increase. The controllability is a problem. So all these things are to be addressed continuously on a year-to-year basis. So there is a lot of research is also happening. There is a lot of opportunities. There is a lot of potential. There is a lot of research is happening in terms of smart grid technologies, in terms of energy conservation, in terms of renewable energy generation, in terms of renewable energy forecast, in terms of voltage control or grid operations, in terms of phasor measurement units and all SCADA systems. A lot of things are happening in tandem insofar as the smart grid interventions are concerned. This basically completes my presentation part, and I am now open to the questions. Sir, Dr. Brahma sir. Hello.
Hello, sir.
Sir. Sir, question, shall we take up question and answer, sir?
Yes, sir.
Yeah.
You have asked any question? Sir is sir, I think no question. No question are asked.
Yes.
Thank you. Thank you very much.
Yes.
My colleague Krishna will give good of time. Krishna, madam, please carry on.
Good afternoon. I take immense pleasure to deliver a vote of thanks for this occasion. Sir explained representation of a typical power system that include right from generation, transmission, distribution, and power. The power is distributed to the consumers. So, basic representation of the power system. Sir has given a very well-known example, that is a tandem bicycle moving at a constant speed with the blue figures, which indicates the road, and red figure indicates the power stations of different sizes. Speed of the tandem cycle is the grid frequency. Sir has focused on this. Next, sir explained the smart grid. What are the additional elements that are required when compared to the conventional grid? Integration of wind and solar, which is larger when compared to renewable energy sources. Sir showed the importance of electromechanical frequency meter and focused on two most important parameters that characterizes the power system are voltage and frequency. It is an electric grid that uses information and communication technology to gather data on information about behavior of suppliers and consumers in automated fashion. That is the smart grid. Sir also focused on the managing the increasing complexity and needs of electricity in 21st century, intermittent issues that are facing today and are compensated by renewable energy sources, generation cost of renewable energy sources, and how the integration into smart grid facing a lot of challenges. Sir highlighted smart grid as not static, but it is continuously evolving process. And next, Indian Smart Grid Forum, comparisons of existing grid and the smart grid. Sir focused on one-way, two-way communication, one direction and bidirectional. Development of renewable energy sources across the country. Setting up the National Solar Mission, in which Sir focused on National Action Plan for Climate Change, that is NAPCC, and Paris Agreement signed on 2016. Target fixed by government of AP, wind and the solar potential. Sir highlighted Rajasthan has most renewable energy potential among Gujarat, Maharashtra, Jammu Kashmir, Andhra Pradesh, and Karnataka. Composition of installed capacity in India. Growth of renewable energy capacity in the country. In this, Sir focused on long transmission line connection, scheduling and dispatch, integration of wind and solar to grid, open access, balancing of power, state and central grid regulatory commission that is required for better operation and the controlling of grid. Sir emphasized on automatic remote control is one of the factors in smart grid technology. Also, AP trans, typical grid demand in a day, features of smart grid or equipment. Smart meter consumption will be the time stamp of data that is recorded and stored, and which cannot be performed by an ordinary meter. Electric vehicles are also being part of the smart grid. Thank you, sir. Thank you for spending your valuable time and sharing your research and practical knowledge with all of us, sir. Thank you, sir.
Thank you, sir.
Yes, sir. I also thank Madam and Dr. Brahmaya, sir, for giving me this opportunity to share my views on the subject among all the participants. And I also thank the participants for their patient hearing. Thank you very much.
Thank you.